Good morning, everybody. Welcome to another BobCAD-CAM trainer-led event. My name is Andrew. I'll be the trainer today. And today we're going to take a look at the V9 mill, so the plugin for SOLIDWORKS. We're going to get started here in about 10 minutes, 5-10 minutes. We'll see. We're going to see if anybody else pops in. We had quite a few people sign up today. We'll get started here shortly. All right, again, welcome everybody to another BobCAD-CAM live trainer-led event. My name is Andrew. We're going to be taking a look at the V9 mill plugin for SolidWorks. So let's go ahead. I'm just going to open up a part file and then we're going to go ahead and talk about the plugin a little bit. All right, now I do not have the plugin loaded, but before I get this loaded, I'm actually going to check out our support site here. So if you go to BobCAD-support.com, this will be your resource for knowledge base articles as well as post-processors. So if you need to get a post-processor for your machine, you're going to see your posting resources here, or you can come up to the top and go to post-processors. Now there is a little getting started to explain some stuff, but there is a download post-processor section. You'll want to click on that. You'll enter your customer ID here. Make sure I close all that stuff out. I apologize, everybody. Bear with me 1 second. All right, sorry about that. I had to close some stuff down there. So you will need to put in your customer ID, select your version. So in your guys' case, you would go to the BobCAM for SolidWorks. You'd select your machine type. So in this case, it would be a mill. And then you pick your machine type. Now let's just pick something pretty common here, Haas. And then you'll have your different posts available for that mill. I definitely recommend checking out this download post-processor section to find a post that matches your machine. If you don't see your controller, you may want to do a post request. That is on another page here. There is a request a new post processor. There's a little video explaining what to do, but really we want all of the information for that machine. So it's going to be your G&M codes, sample program, any CAM cycles or anything you're using. We do show a list of the supported CAM cycles, so if you're using any CAM cycles for like pocketing routines, things like that, we don't support those. Mostly just the drilling, things like that. All right, so let's go ahead and take a look at the SolidWorks side of things. Now, I do not have my plugin loaded. The first thing we're going to want to do is come up to our little options section up here. And I'm clicking on that little down arrow and going to add-ins. Now I am in SolidWorks 2021 at the moment. So it may look different than yours if you're on a different version. And I'm going to turn on the SolidWorks plugin. Now I don't typically have it turned on startup. That's just my personal preference. You can absolutely set it to run on startup. It just adds a little bit of time sometimes to the launching. Let's go ahead and turn on that plugin. All right, so now that the plugin is loaded, we have these 3 extra tabs added to our little feature tree. We're going to have our CAM tab. This is where all of our CAM data is going to go, so all of your tool pathing once you've designed your part. You have your BobArt manager for any of you guys that have BobArt. We're actually not going to be getting into that today. And then you have your posting window. So when you actually post your G-code, it will populate in this window. Now, you may also get the BobCAM tab. So there's a few things in here that are pretty important. You have your settings, which for the most part, there's not a lot here. Generally, the settings in our standalone is mostly CAD settings and do tolerances to drawing and things like that. Since we're doing all that with SOLIDWORKS, it's going to be pretty minimal. It's going to be just about the mill, or just about the CAM side. So there's enable CAM tree flyouts. We'll talk about those a little bit later. We do have data collection. Now, the data collection that we do is not in identifying data. This is just if you use a feature and how often features are used. So if you use a profile finish and not profile rough, we'd see that. Other than that, we're not seeing any additional information. We're not looking at your system. We're not looking at anything else except for what features you use within the BobCAM plugin. Then we have our document and current document defaults. Now, I have my SOLIDWORKS set to 2 decimal places. It is running at 4, so our system CAM tolerance is 1/10 of a thou. On the 2-axis, our chain select should be 1 thou. Spun profile, I believe, is 5/10 or 5 thou. No, yeah, 5/10, sorry. Which we're not doing that since we're not looking at lathe or mill turn. And the 3-axis should be 5/10 of a thou tolerance by default. Now you have your default machining order. Now this will come up every now and then. You'll notice that I do have different options set to each one of these. For milling, I usually set it to individual tool per machine setup, and we'll talk about those specifics a little bit later. Now I do want to also add, if any of you guys have any questions, by all means, you can type them into the question box within the GoToWebinar panel. We are going to kind of reserve a little bit of time for Q&A around 11:30 or so Eastern. So if you do have any questions and they're not directly about what we're talking about, try to save them until then. And lastly, you have your toolpath color. So we'll just go ahead and hit apply and OK to close that window. Then we have your new CAM job, which you can also get to under this quick access toolbar under the CAM tree or by right-clicking CAM defaults. You have your simulation up on this bar as well as exit simulation. Your NC editor for sending to the CNC or just editing your G-code. You have your utility. Oh, and I forgot exactly what. So this is their templates that we have. We'll take a look at this a little bit later. I'll probably show you guys the help system since I don't have anything directly prepared for this if we get to it. It's really not that super important right now. And then lastly, here we have our knowledge base. So the knowledge base is how we identify holes. So the parameters of a hole to require certain types of toolpaths. So we have a hole recognition that will automatically set up toolpath for you. We're going to take a look at that a little bit later. But this is the rule set for those holes, how they handle them. So for instance, if I have a chamfer and the chamfer is less than 625, it's going to use a chamfer drill. If it's greater than or equal to 625 or 5/8, it's going to use a chamfer mill. So you can set up the conditions for different types of tooling. Now you still have to go in and make sure the tooling matches what you actually have, but this will get you really quickly programming a bunch of holes all at once with only minor edits. You know, how you handle pecking, your parameters for countable holes, tapped holes, and countable tapped holes. We are going to look at the feature recognition, or the hole recognition a little bit later. All right, so we have our SOLIDWORKS plugin loaded. We've taken a look at some of the settings that we have. But again, we don't have very many that you have to worry about. So let's take a look at actually applying some stuff to a job. Now, actually, before I do that, let's go ahead and right-click on CAM defaults. So like I said, you do have new job at the top. There's also new job from template. So the templates are new for users to kind of predefine their job and load it in. So those templates can hold things like the stock information, material, the size of the stock, toolpaths that you may have used on a previous job, and it just loads all of that in. So especially for people that are running, like, say, routers or laser plasma water jet, where you're running a lot of the same size material, you can set up a template for that material, and then you're just putting your parts in that area. It can be pretty handy. Then we have our current settings, so we're going to take a look at that real quick. So in this current settings, you have your maximum spindle speed for the machine selected. You have your maximum cutting feed rate for that machine, and this can be different for every machine. So if you have multiple machines in your shop that have different parameters to them, different spindle RPMs, different cutting feed rates, you can modify per machine by adding a new machine here. If you download one of our posts from the website, like I just showed you guys, it will actually set that machine to your default machine. So whatever you select and install, it's going to set it as default. You don't really need to worry about all this. Now, the maximum number of tools doesn't actually do anything. You don't need to worry about it. But the rapid feed rate does calculate into the total cycle time. So if you're using our setup sheets for cycle times, you're going to want to set that to whatever the machine's rapids are that you're running. And again, you can set that per machine. You have your machine definition, which generally I'd say don't worry about. If you're using a 3-axis machine and you need to build one, it's a very simple process of actually just selecting 3-axis machine, and we build it automatically. Not very many reasons for you guys to really mess around with the machine definitions, and it can actually affect the way your code outputs. Then you have your posting. Now the posting page here, you can set your default post processor. Again, if you download a post from our website, it's going to set it not only as the default machine, but it's going to set the post for that machine. I believe most, if not all, of the posts on our website have machines built and associated to them. Then you have your NC file path, which you do not want to change that directory. If you change that directory, you may or may not be able to post your code. Then you have your file extension. So for those of you that might have specific file extensions you need for your controller, you'll want to enter that here so it automatically sets that when you post. You have your default program number, which you can change on the fly with the flyout menus, and I'll show you that a little bit later. This is just the default number that we start with. Your sequence numbers, which a very nice little feature here. If you don't want sequence numbers, you just set both of those to 0, and it won't output a single one. But you can set it to, say, start at 10 and do increments of 10. Lots of different ways to kind of set this up. Numbering for subprograms. If you are going to use subs, you definitely want to make sure you get with our posting department to make sure everything's kosher so it all works. And then for those of you that have maybe multi-axis, we do have transform planes, like the dynamic work offsets. Haas typically runs into this more than most, I believe, but we do have a machine that does dogleg rapids. It essentially just converts your rapid to a feed move and sets it as the maximum feed. And then the output arcs and 4-axis, honestly, in the 8 years I've been here, I've never seen that needed. And then the automatic comments. Now, every post may have some automatic comments. Those can be disabled, but you might still have comments in your code. So if you're trying to get rid of specific comments, you're more than welcome to give us a call and we'll help you out with that. And lastly, you have our multi-axis posting. For today's purposes, we're actually not going to be looking at this at all because we're not doing any multi-axis work. We're just looking at basic 2- and 3-axis toolpaths. And if you do have a multi-axis machine, more than likely we're going to handle all this stuff for you when we get the machine definition info, which we can help you collect if you need. All right, so we'll go back up to CAM defaults. Let's continue going through the other options here. So we have our cutting conditions. Let's go into that real fast. So these are just some of the parameters you can set for, say, drilling. How much it adds when it does a through hole. So when you set a drill to a through hole, it's automatically going to add 50 thousandths to your overall depth. Now we're adding in the tip angles, so as long as you give us the tip angle information correct, you're going to get an accurate hole depth. You have your PEC increment. We do 50% of the tool diameter by default. You can change this per job too, by the way. So I'm going to only go over the real important information here on this one. Really, the only other field that I ever kind of go over is these chamfer cutting position. So if you're doing chamfering, if you're doing edge breaks, this value is how much you're kind of offsetting that tool for the lack of a flute or the radius on an insert or whatever it may be. Whether it's a flat bottom tool, you have to compensate for a little bit of a radius on the insert, or if it's a sharp tool and you don't have a flute right at the tip. That's how much we're offsetting the rest of the tool path. So that one's actually a really important one for chamfering. The rest of these values in here really don't make too much of a difference for you. And some of them don't do anything at all. Then we have our DMS defaults. So these are our default strategies that we have. We're going to take a look at that a little bit later where it might make more sense. We have our tool library. Now, the tool library is kind of like your public library. It's going to have a bunch of stuff that you're not necessarily going to need. Don't worry about deleting them. We have a lot of people that want to delete out the entire tool library and put only the tools they have in there. And that's great and all, but the tool library is actually kind of a fragile file, and it can get wiped out. I've seen it happen from Windows updates. I've seen it happen from really odd things like security programs will delete it out. So if you're one of those people that want to define all of your tools, you can define them in the tool library, but you're going to save them in a tool crib. The library is all the tools accessible to you. So this is going to show you all your drill types, your in-mill types. So this is going to be your T-slet cutters, chamfer mills, corner rounding, thread mills, all of those kind of tools. Your turning tools, your probes, laser, plasma, and water jet. So this is not the place that you want to go and define and try to save all your tooling. Now, however, to define a tool, let's just go to in-mill rough here. You'll click on the little add button, and it will add a blank tool at the bottom. So if I expand my tool parameters here over on the right, I now have a label I can give it, diameter, flute length, corner radius, and you can go crazy defining them. But I really wouldn't worry about too much of the information. For instance, flute length is not really that critical. Tool length might be critical depending on the length of the cuts you're doing, the depth of the cuts you're doing. We will actually generate tools automatically for you though. So let's say, for instance, you do a drill and it's a 3-inch depth. We're automatically going to generate a tool that will accommodate that. Same thing with 2-axis. If you give us a depth of 2 inches for a cut, we're going to make sure that the tool that you have automatically selected can do that. It doesn't mean you can't go and select a different tool. It just means that we're going to automatically generate one. So what happens sometimes is it may change tool numbers on you because you think that it's the tool that you wanted to define, but really it just created a new one based off of what you've entered to define one that works for the cut. So they may not get the tool numbers you want. So I don't really worry too much about tool numbering at all until the end of the program. You can also set up speeds and feeds per individual tool. So for people that are running a lot of the same material all the time, you can set up all the tools that you use, and especially if you're not using a wide variety of tools. You can go in and define the spindle RPM, plunge feed rate, and cutting feed rate on that tool itself. So whenever you select it, it's automatically going to be there. However, just keep in mind, if it does automatically generate a tool, it's not going to have your speeds and feeds. You're always going to want to double check that. The other thing in here is you can assign tool geometry. So if you have a custom tool, maybe you have a spot drill that will chamfer and counterbore all at once, you can draw that tool up so you can see it in simulation. But really, that's all that's there for. So if you have form tools, things like that. Then we have your mill tool holders, which we're not really going to take a look at today unless you're doing 4 or 5 axis work where you're getting really tight, intricate, deep cuts. You're probably never going to need to worry about those. The adapter library only applies to mill turns, so we're not going to take a look at that today. But we will take a look at the thread library. So you have your basic tapping groups and some. You have your UNF, UNC, UNM, UNS, NPT, NPS, there's metric course, metric fine. You'll have all your basic types. Now, if I just go into UNC, we're just going to grab quarter 20. We have a lot of taps already predefined. And when you do a tapping toolpath, we're using this information for the speeds and feeds and what drill to use for that tap. So if I just grab, say, the quarter 20 here, I just saw it. Oh, yeah, I already have that highlighted. So I'll click Modify Thread just to show you what information we're looking for. You have your tap label, so whatever you're going to call that tap, the major diameter and minor diameter, which major is the only one that really matters. Minor matters if you're doing thread milling. Your pitch, which definitely matters because that's going to set our feed rate for tapping, and it's going to set the pitch for thread mill. Your thread angle, your taper angle if you need it, and then down at the bottom you have your hole size. So this is the drill that it's going to use for whether it's a cutting tap or a rolling tap or a form tap. Now, keep in mind, there's literally no difference in G-code, whether you're doing a cutting or rolling tap. So those drills are not super critical for you. Plus, it's a drilling toolpath. It's centerline. You could really put in whatever you want in there. It doesn't have to match exactly what's in the program. The tap does because it needs the pitch to be right. But for the drill, for the tap, it doesn't have to be exactly what we have. Now, the last thing in here is our material library. Bear with me 1 second here. Hold on. All right, sorry about that. Now, the material library only matters if you are using the automatic speeds and feeds. So if you're depending on us to output your speeds and feeds for you, you're going to want to make sure that you fill these materials out to match your tool manufacturers for the material you're cutting. So what I mean by that is let's just grab a material here. It doesn't really matter which one it is. So with the material library, you're going to want to define this yourself based on what your tool manufacturer recommends for each different type of material. So if you're using a carbide cutter, you'll have your surface footage. Oh, that's weird. Set the metric for some reason. I'm set the inch. Oh, interesting. I'll have to find out what's going on there. But you can set your surface footage for that carbide insert, that carbide end mill, your chip load per flute. You can even set custom speeds and feeds per operation type. However, this is just going to get you in the ballpark. You're still going to need to monitor your speeds and feeds and double check everything. I don't personally like using the material speeds and feeds. It's nothing against them. It's that I like to calculate my speeds and feeds myself. There's tons of different ways, formulas and information out there that you can get. You're going to want to double check with your tool manufacturer for the tool you have to get accurate speeds and feeds. So we're not going to really worry about the material too much. And let me double check my, yeah, I'm set to inches. It's interesting. I'll have to report that. All right, so now we're going to go ahead and do a new job. So when you start up a new job, you're going to see milling, turning, and mill turn. Now you may only have milling, you may only have turning, you may have both, you may have all three. It's dependent on your license. And then you're going to see the Start Stock Wizard. I usually keep that checked so that when I hit the green check mark, it'll move on and start my Stock Wizard. I've set my machine, and then you do have default parameter templates. So there is a job from template that is saving the entire job out and loading it in. So that could be your tool path, that could be your stock size, that can be a lot of information. The default parameter templates are for settings. So if you have one particular type of material where you want a specific step over and depth of cut, you can set that parameter type and load it in here. If you have a different material besides that that has a different set of settings, you can save those and save them to a template. Those are just setting templates. We're going to go ahead and hit the green check mark here. Then it's going to ask for a workpiece. Now, if you have a solid, which you're in SolidWorks, presumably you're always going to have a solid, you're going to pick that as your workpiece. Now, if you're not doing any drilling or you're not having any fixturing or anything, you're really not going to see anything that it does. The workpiece is there to help us define the stock. So if you're running an assembly, maybe you have your fixturing, you're holding a bunch of parts, it'll define what parts you're cutting versus the fixture. It'll tell us what the part is versus the fixture. And if you're drilling, it'll show you a little 3D view of your file, of your model, in the drilling wizard, which we'll take a look at that a little later today. So we'll just hit next. Now the stock is automatically going to get defined based on my part. So this is 3/4 inch thick, and I can see that right here. And it's a little less than 6 inches X and Y. So I'm actually going to turn on enter here. And we're going to change that to 6 by 6. And I can see that stock is a little bit bigger than my part now. Now the stock model size is not really super critical. We don't look at the stock model at all for the toolpath for 2-axis. For some of the 3-axis toolpaths we do. Actually, all of the 3-axis toolpaths look at it a little bit to some extent. 2-axis, it could be a 1x1 little cube. It could be way bigger than your part. It really doesn't make any difference at all. It's just for simulation. So we'll go ahead and hit the little next button at the top. The one thing that the stock is very important for, though, is helping you set your work offset. This last page, we're actually setting our work offset, our G54. So if I normally work off, say, the back left corner, I can pick up this corner. If I didn't set my stock right, it would actually be inset a little bit, that few, whatever, 100 thousandths or whatever it was on either side. So just be aware that your stock definition can help you define your work offset. And if I actually go back a page, you can set additional offsets down at the bottom. So if I only needed to add a little bit to -X and +Y, I can say I want 250 added to -X and 250 to +Y, and that sets that corner a 1/4 inch away. So you can use these offsets to do the same thing if you're working off a corner. If you're working off of the center, it really doesn't make any difference, because the center of your stock is going to be the center of your stock regardless, even if you put something smaller than what you can cut. All right, so my origin is set. You can flip these axes if you need to. So if your part's not oriented in the front plane, you can reorient your coordinate system here. I don't know if I have any parts that are not in the front plane, so I don't know if we're going to take a look at that or not, but we'll see what happens later on today. Now you have your clearance plane. That gets used on drilling, depending on if you're outputting G98 or G99. It gets used at the beginning and end of file, and it gets used at tool changes. Now its use is very quick. You're not going to really see it stop at 1 inch. However, it still has to put the rapid in there. So we do have some people that want to remove that 1 inch, but unfortunately you can't unless you just manually delete it out. But that'll help you kind of go over clamps and other things that may be in the way. And then down at the bottom you have your work offset. This pick a point and this value down at the bottom is really for if you have fixturing and if you're using Machine Simulation Pro. If you're not using Machine Simulation Pro, this will not matter down here. The only thing that will matter is the work offset number. So number 1 is G54, number 2 is G55, and so on. So depending on what work offset you're using, could be E1, E2, E3, depending on your machine, but that's your work offset number relative to your post. So we'll click the green check to OK our stock and our machine setup. Now you're going to see the machine setup origin disappear. If you left click on machine setup, it will show it on the stock again. But I actually want to hide my stock. I don't really like to show it very much, so I'm going to right-click stock and go to blank unblank. You can also go in here and set a default transparency. So if you want the transparency to be a little higher so you can see through it, you can set that up under that stock definition under the right-click menu here. All right, so let's go ahead and take a look at some of the toolpaths. So now I have a milling job, and if I right-click milling job, I have a lot of the same stuff that I had under the CAM defaults. I have current settings, I have the cutting conditions, but I have a bunch of other stuff. So this is just relative to this job. So if I go to current settings first, this is the same dialog box we looked at earlier with one exception. It doesn't have the machine definition, but it does have a comment section. So you can't change the machine definition, but you can add in comments. Now, these comments are going to be at the beginning of the G-code. You can output 15 lines of whatever you need to. So if it's information for work offsets, if it's just information for the operator, so they know, 6 months later, if they have to rerun the part, what they had to do to set up. Maybe little things like, hey, we had a 1/2 inch this time, but double check tools for next time. We may need to change them, things like that. The comments can be very handy. So under the milling job, you have system default. Now those are the templates that I was telling you about. So that's your settings template. You have your machine you're using, and if I expand that, I see my post processor for that machine. We have our milling tools. Now, if I right-click on this, we're going to have the tool crib. So as I said earlier, if you're one of those people that have the same tools in the machine all the time, you're running pretty much production jobs, or you really just don't have a lot of variety in your parts, and you just have the same tooling all the time, you can build out a tool crib. Now, this is where you would save your tooling. Again, you don't want to save your tooling to the tool library. You want to use the tool library to populate your tool crib. You can save the crib separately, so you don't have any risk of it getting deleted out. You could even take it to other computers. So even another computer that may not have all your tools, you can still bring your tool crib over to it. And it's as simple as just clicking on a tool. Let's just grab one. I'm going to go to InMill Rough and add from the tool library. Now let's just say I grab a 3/8 flat end. So now I have a 3/8 defined in my machine as tool number 1. It's going to automatically number it as number 1, so just keep that in mind. Again, tool numbers, you want to wait until the very end of the program, or very end of the process before you change it. Now under the milling tools, you have your workpiece, which highlights the model you've selected, your stock, which if you click on it, it highlights the stock model you've defined. And again, the machine setup will show where your origin is. Now, each one of these do have flyout menus. It gives the clearance value, the work offset on the machine setup. The stock's going to give you the stock size. Milling tools will give you a tool list that are used within this program. And the milling job, you can change your program number, and you can set up, you can see actual feed times, rapid times, total times, the whole job. And those flyout menus change depending on what operations and stuff you're looking at. So I'm going to right-click Machine Setup 1, and we're going to go to Mill, you know what? 2x. Yeah, we're just going to do Mill 2x's. I'm going to show you guys a couple of things. There's a lot of different ways to approach programming within the SOLIDWORKS plugin. One of the first ones is I'm going to just hit Select Geometry, and I'm going to pick the entire model. And actually, let's do that a different way. I'm going to clear my selections. I'm going to turn on Select Whole Bodies and just select that solid and hit OK. you'll notice that it created multiple features for me. So if I hit next, I can see the first feature is a facing feature. So this is giving me a total depth and top of feature of 0. So this is just made to face off the part. Now I'm probably not going to want the facing feature. I'd probably want to use this as a profile since it's going to cut the outside. Feature 1 is the inside pocket. It automatically defined those based on how I drew the part. So these can change depending on how you've actually made your solid model to begin with. So let's say the total depth, we're going to click pick bottom, and I'm going to pick that bottom edge. When I right click and hit OK, I now have the depth of 3/4. Now it doesn't matter that I'm doing the inside first because I can always change that. So I have my default strategies up top. Now these are the dynamic strategies that I was talking about earlier, DMS defaults that we skipped over. You can change what these templates are. So the default templates, profiling is going to give you a profile rough and a finish. Pocketing will give you a pocket with a finish. Facing is just facing. 2D engrave is just engrave, and so on. You have your chamfer, plunge rough, drag knife, and down in the corner you do have a corner round. There it is. Additionally, they just didn't add it to the strategies. Now we're going to do profiling. Now we'll hit next. Now you do have tabs, so if any of you guys are doing laser plasma water jet, tabs can help hold your piece to the sheet. You just break those tabs off. Milling, it's kind of a toss-up whether you want to use them or not. It just depends on the material, your work holdings, a whole bunch of stuff. If you need more information on tabs, we can always do some online training. We do have other training options available. You have your posting page, which is essentially just setting up your work offset number. And then we have our tools. So the first tool, it's going to use that 3/8. Now it automatically pulled the 3/8 end mill because it's the only tool in my tool crib. If I didn't have that tool in there, it would have grabbed a 1/2 inch end mill. And we're going to see that on the finish. I'm going to leave it the 3/8 and we'll hit next. Now you would want to set speeds and feeds. Ignore the tool numbers though. And actually, I'm going to go back 1 second. You can just uncheck this box here and fill in the speeds and feeds info. You do want to make sure that you set the number of flutes though ahead of time. So if you're using like a 6 or 7 flute end mill, make sure you set that first before you fill out the rest of the info. Then we have our patterns. Now I'm just going to do a standard pattern. It's just going to do a depth around at whatever depth I tell it. You also have contour ramping. If I can talk today. Contour ramping gradually cuts down in Z as it goes around the part. And then you also have side roughing. So if you have an even amount of stock that you want to remove from the outside of the part, you can step in however much stock remaining and the number of passes, or you can give it a step over you want and how many passes you want. So you have a couple options with side roughing now. You can even do a zigzag pattern. So after each cut, it changes directions. But we're going to leave it on standard. And then we have our compensation. Now the compensation does confuse a lot of people at first. If you have any questions on compensation, you don't know anything about it, let us know. We can help you understand it. But we're going to be doing climb milling. So that means I'm going to be left of whatever my profile is. Whether the side of the line is irrelevant right now, but left would be climb. If you don't understand what climb is, we can always help kind of break that down for you. And I'm going to avoid the machine compensation for right now. We'll explain more of the compensation a little bit later. Next page is our depth of cut. So this is how much we're taking per pass. So you have a side allowance, which by default on a profile rough and pocket will be 15 thousandths. So that means it's leaving 15 thousandths per wall. And then you have single or multiple depths. Now if I turn on multiple steps, it's going to do even first, and it's just going to split up my total in half. Whatever value I enter in here, so if I enter 0.2, it's going to round that to the next even increment. If I do define depths, if I entered 200 thou, it's going to give me 200 thou per and then split the difference for the last pass. And then you have your, let's go back to even, let's set that to, oh, I don't know. We'll do 250. You also have a minimize retracts, so it'll actually, when it leads out, it'll plunge to the next depth instead of retracting all the way up to the feed plane and then all the way back down. And you can do a zig or zigzag pattern on depths of cut now. Then we have our lead in and lead out. Now, if you're using machine compensation, which I know we didn't talk about, but that would be your G41 and G42, you're going to want to make sure you do a right angle, circular, or blended lead. I'm just going to do this as a right angle. Now let's give it a length of, I don't know, 100 thousandths. If you're not using machine comp, system compensation automatically applies the radius of the tool to the path. So it's already offset for half the tool size. This right angle lead is just how much I'm using to approach that cut coming in from the side. Then we have our corner types, which we really don't need to change. Mostly, I'd say almost 99% of our users are not going to really utilize this too much. Machine sequence, this only applies if you're using multiple parts, if you're cutting multiple things. And then lastly here you have your advanced feed rates. Now the advanced feed rates is on every single toolpath, but the information here changes depending on what type of path it is. So in this case, it gives us a corner slowdown option, lead in, lead out feed rate percentages that we can change, and you can convert rapids to a feed rate. Next, we have our profile finish. So this automatically ended up getting a 1/2 inch flat end mill because I didn't have any tools defined yet. I'm just going to type in here, let's do 3/16. It automatically pulls from the tool library. Now, if you have a tool already defined in the tool crib, it's going to pull that first. And again, you want to set your speeds and feeds, uncheck this box to do so. And if you need to change the number of flutes, make sure you do that first by unchecking system tool and changing it here. This will affect the speeds and feeds calculation, so keep that in mind. Now, I kind of skimmed over the compensation on the last one. We'll talk a little bit more about it. Like I said, system compensation, BobCAD is doing the work for you. It's offsetting the tool in the G code. The downside of that is that if your tool changes size, if it's worn or if you put in a reground tool, your diameter is not really the same anymore. So that's where machine compensation comes in. Machine compensation, we give you tool path directly on the profile you select, and then the machine offsets for the radius of the tool. The benefit of this is that, let's say you program for a 3/8, but you realize you don't have one. You can load in a 1/4 inch end mill, you set your compensation at the machine, and you can use that same profile. Can't really do that with system comp. Now, me personally, I use both. So I compensate for the radius of the tool, and then any additional wear, I can put that difference in the machine, and it'll adjust it for me. I used to do a lot of production cabinetry, and that worked out really well, so I always had accurate sizes, even if in the middle of the program I had to change it. Now, the next page, we have our depths of cut again. Now, because this is a profile finish, it does no side allowance, but I am going to do multiple depths and turn on the minimize retracts. So it does 3/8 per pass, 2 cuts. Now this time we'll do a different lead in just to change it up a little bit. We'll do a circular lead. Circular has a lot of settings to it. It can be really powerful if you know how to use it right. So the line is the top box here. So if we look at this little diagram, and if you're ever not sure what something is, try clicking on it. It'll usually show you an image of what it's trying to describe over here. So right angle, the lead is 90 degrees to the start of the radius. Tangent, it's in line with the radius, tangent to that arc. And then user defined, you can put in whatever angle you want. Now let's go with tangent. I prefer tangent. I don't like to do a lot of sharp moves on a machine. I try to minimize that as much as I can. And we'll adjust the length down to maybe 100 thousandths, and the radius will do 100 thousandths. Again, if you're using machine compensation, you're going to want to make sure the length and radius are at least the radius of your cutter. most machines require that at least. I usually add a little bit of additional just to compensate for allowances. Now the sweep angle, we can actually adjust how this kind of ramps in. So rather than doing a 90-degree turn coming in, I can tell it to do 45. And that'll lead in kind of a little smoother and a little smoother out. Sometimes that cleans up any hard witness lines or anything on the edge of the part. You also have an overlap. So I can tell it to pass the lead in by 100 thousandths or so before it leads out of the part. We have our corner types again. On this part, it wouldn't do anything at all, so we'll just hit next. Our machining sequence, which we don't need. We only have the one shape. And then the advanced feed rates, which again, we don't really need here. So now it takes us to the next feature automatically. So in this feature, this is that internal pocket. Now the cool thing here is it's already told us the depth. It's already figured that out based on the feature, the extrude cut that I used to make the part. So I don't even need to set a depth as long as I've picked the model correctly. Now this one we're going to do pocketing. I don't need tabs. Tabs only work on profiling, by the way. Even though it's a page that's there in the 2-axis wizard, it only works for profiling. We have our posting page, which we don't need. We've already got our 3/8 end mill in there, so we're good there. I'll just hit next. Again, you would want to set speeds and feeds. But now pocketing has a couple options. We have standard pockets, which are going to be a parallel, offset out, offset in. We'll just leave it on offset out. And then you also have advanced pockets. Now these are made for open pocketing, as you can see here in this image. Morph spirals, so they take the shape of whatever profile it's doing and spirals that. And then there's also the high-speed or tricotial or helical milling, whatever you want to call it. There's tons of different names for it, but in BobCAD it's the adaptive roughing. But we're just going to go ahead and set that to offset out. Now, if you're on standard, you also do have the use spiral for circular pockets. I usually just leave that on. If there's not a circle, it's just not going to spiral. We have climb or conventional. So if you're not sure what these are, you can click on them and they will show you the cut direction. Just understand your tool is spinning clockwise, moving around. So climb, it's actually kind of scooping along that cut. That's why it's referred to as climb milling. Where conventional milling, it's kind of tearing that material away. It's peeling it, and it's actually cutting it conventionally as it goes around. But you can see conventional, you're always on the right-hand side, where climb, you're on the left-hand side. Doesn't matter which way you're going, you're on the left side of that line. Then you have your step over. I like to go down a little bit. I don't like to go right at 50. I usually go to 40, so I make sure that I'm only doing climb milling. And we have our side allowance. Now again, that is 15 thousandths. I just have my decimal place set to 2. And you have single or multiple steps. I'll just do this one in a single pass. Lead in and lead out. Now this has just the plunge where you have a pack or fast pack option or single depth. You have a ramping option or a spiral. I would say be aware that the spiral does not care what your geometry is. So if you define your radius too big, you potentially could gouge the part. So just double check your ramp length or radius value for that. Then you have your angle of approach. That's how much it's actually spiraling down. Let's say 7 degrees. And then the tolerance of that spiral. We have our machining sequence, which we really don't need here. Our linking. Now you'll see that there are no options. Different pocket options give you different options for linking. So keep that in mind. And then you got your advanced feed rates. Now the profile finish, it is pulling in the 3/16 that I defined from earlier, so we're just going to hit next. We're going to keep it on left compensation. I'm going to do this in a single depth. It's only taken out 15 thousandths. And on the lead, I'm going to use the last one here, the blended lead. And again, I'm going to use the same 100 thousandths length and radius, so you can see how this one kind of draws it out. Essentially, the blended lead in and lead out creates a teardrop shape that the tool uses to plunge in and leave so that it's in the exact same position where it enters and exits. We don't need our corner types, we don't need the machining sequence, and we don't need the advanced feed rates. So I'm going to go ahead and hit compute. Now you'll notice I have toolpath on the inside, but I have these purple lines here. That means my toolpath on the outside is on the wrong side of the line. So to edit that, I want to right-click Default Change Start Point and go to Modify. I also want to change where it's entering. I might want to move that somewhere around here. So by clicking on that profile, I can move the entry, and by clicking that profile or clicking that arrow, I can reverse the direction. So I'll hit OK. Then I'll right-click the feature and compute all toolpaths. So now that's given me my internal and external cuts. Now this is one way to program a part in BobCAD. Now let's go ahead and run simulation real quick. Now we're going to talk about other methods of selecting these things. Now in simulation, you do have some visibility options, so I can hide my workpiece, I can show my stock, I can make it transparent. You can turn off the toolpath, you can turn off the tool, you can make that transparent. There's quite a bit for visuals. You can even change your toolpath rendering, so what it shows on the screen. By default, it's showing everything, like so. I usually turn mine to show current operations and only a segment of the current operation. That way it just looks at a little portion of that toolpath. And I'll just go ahead and hit run. It's running pretty slow, so it should be a pretty smooth simulation here. Let's speed it up a little bit. Now it is doing the outside first. Now, I definitely wanted to do the inside first, so I need to change that. Now we'll let this simulation play out, and then I'll show you guys how to change that setting, or change that order. And it's also using each tool completely before it moves on to the next. So because it had used that same 3/8 end mill to rough everything, it did all of that first before it went and did the 3/16. So I want to change that machining order. So if I right-click milling job, it's the second option down. Now you're going to get a little window that's going to show you the tool numbers, what feature, and what operation they're in, as well as the work offset and machine setup. Even indexing and wrapping groups if you have them. Now, one of the things to keep in mind, I can't move that pocket below the tool that finishes that pocket. I can't take the tool that finishes that pocket above it because they're within the same feature. But toolpaths that are in separate features, we can absolutely move around and change where they're at. So I want to do the pocket first. I'm actually going to tell it to not do the rough. So it's going to do the outside last. So it's going 1, 2, 1, 2. Now I could switch this up by telling it individual feature instead. That will actually put it in that order. Put it in the order that it is in my tree. I want these two to be at the bottom and these two to be at the top. So I need to change that around a little bit. Now individual tool per machine setup, we'll set these in the order of the tool number, but based on the setup. So if you're running G54 and G55, it will separate those out. It'll do all of G54 and then all of G55. If I set it to individual tool, that's for if you're running multiple vices that you want to run all at once. So if you're running 54, 55, 56, it'll run that 3/8 on all three before changing to the 3/16. Now I do want to do the inside pocket first. So let's just go ahead and move that all up. And it's going to do the rough and finish on the outside last. So when I hit OK, that's going to be represented in the simulation now. So when I go back to simulate, it should be in that order. So I can see my spiral. And then I told it to change tools to finish, and then it goes back to the 3/8 and finishes the outside. So you can fully customize the order of operations despite the order that they are in the tree. Apparently, I brought my stock in on this side a little bit, and I didn't even notice it. I'm going to have to adjust that. All right. Now, I might want to get rid of everything else in the simulation just to see what parts remaining. So if I go down to measure, I already have mine set to off, but if I click on this drop-down menu and select only keep one part, the remove chips here, I select the middle mouse button. I've used the middle mouse button to pick the model just by clicking on it. And then everything else will drop out. Now the left mouse button will rotate in here, and the right mouse button will pan. So I can see my final part. Now I need to adjust my stock, so let's do that real quick. I must have hit the mouse wheel. SOLIDWORKS allows you to scroll through some of those dialog boxes and change values, so I bet you, yep. Still didn't add it. There we go. Now, I can also set up a job a little bit differently. So I'm actually going to delete all these toolpaths. And we're going to do the same part a slightly different way. So when I right-click on machine setup, one thing that we haven't talked about is there is a facing operation. Now, when I selected the entire model, I had to do that under a mill2 axis so that it could develop each type of feature. It defines each one. When I do mill facing, I don't even need to select anything. It actually reads your stock geometry and defines the area to cut. We're going to do a total depth of 0. Just going to make sure that's actually 0. And the top of feature is 0. So we're going to face it off, creating Z0. Again, where their stock material is kind of irrelevant. So we just have the one facing operation. Don't need the posting page. Now it's trying to use that 3/8 end mill. Let's just bump that up to like a 2-inch. Then again, you do want to set your speeds and feeds. Now facing, you have a zigzag operation type. You have a zig, cutting one direction. And then you also have adaptive, so that's constant tool engagement again. We're going to just do zigzag. Primarily, that's the only thing you'll ever need. And then there's two settings here, on or off workpiece. Off workpiece is an additional value you want that tool to leave the part. So I say additional because if you're on off workpiece, the tool is already coming off of the part completely. So with a 2-inch cutter, it's already coming off an inch. This would add an additional inch to the edge of the tool movement on the edge of that part. So 0 would take it right to the edge of the part, 100% off the part. on workpiece is a percentage of the tool diameter you want to leave on the part. So if I wanted to leave half the cutter on, I'd say 50%. Then the center of tool would actually run at the edge of the stock. 25% will leave a quarter of the tool on. So of a 2-inch cutter, it'll leave a half inch of that tool on the part when it changes direction. Doing 0% takes the tool completely off the part. So it doesn't really matter which one you're doing here if you just want it to come completely off, but if you need to have a little extra room, because maybe your stock might be a little bigger, you can always add that here with your off workpiece distance. Give your cut direction, X or Y, and you can also do a custom direction. You're just setting an angle with that one. Give your step over, let's go 40%. And then you have a first cut offset. So first cut offset really helps out if you're doing, say I only had a 1.5 inch wide piece of stock. I can use the first cut offset to adjust where my toolpath was for the 2-inch cutter to go right down the middle. I just put it at positive 3/4. Positive value will move the tool into the part. A negative value will move the tool away from the part. So keep that in mind whenever you're using this. This is the value to adjust your toolpath. Then we have our parameters. I'm just doing a single depth. It won't even let me do multiple depths because I told it to take 0 off. Then you have the lead in. So I'm already coming off the part 1/4 inch. I don't feel like I need an additional lead, but you can always add an additional lead in that's going to be extra on top of the off workpiece or on workpiece value. So especially if you're doing on workpiece at 50%, you would want to put in a length here to start off the part to move into it. Because typically those cutters are only side cutting in mills or shell mills or fly cutters. Then you have your linking. So direct link is just going to do a 90-degree turn, where arc is going to do a radius. Now, I've run into a couple of questions before where people have asked if this can be converted to a rapid for large parts where your stepovers are huge because the end mill is huge. Now, what you can do, you can't convert it to a rapid, but you can use arcs, and on the tool page, there's an arc slowdown. So if I wanted to increase my feed, I just put a higher percentage here, and it's going to move faster on that linking move. Just a little secret hidden thing that I found that a few people have actually used. We'll hit next. And then the last page is our advanced feed rates. We really don't need anything here, so we'll go ahead and hit compute. So now that faced it off. So we didn't need to select any geometry at all for this one. Facing will do it all for you. Now when you go to select just a 2-axis operation and say all I'm doing is the pocket on the inside, well, I have a couple of different ways to select this. I can click select geometry and I can pick that surface, and if I hit OK, it shows you that geometry and the depth. I can pick the edge. I can do a loop selection. When I do the loop selection and pick the top, though, it doesn't know the depth because it's actually referencing from where I grabbed the geometry. So if I picked the bottom edge, it would give me the 3/8 depth. The other method, which is the ideal one, is to actually select from the menu. So I can click Cut Extrude, and if you design your parts in the method that you're going to machine them, you can just pick those features out of the tree, and it's going to define the top of feature and total depth for you every time. See, if you've defined those features properly. Now, it is dependent on your design and how you made that design, so that can be a little difficult to kind of work with. Sometimes you're going to have to pick edges. Sometimes I actually create sketches just for toolpath. There are some times where if you're selecting stuff that's on multiple sketches, it can kind of pick kind of weird. So sometimes you'll have to create a unique sketch for a toolpath. But generally, if you build your part the correct way for machining, you just pick the features for that machining or for that feature, and you're good to go. Now, I'm not going to go through all the settings. I'm just essentially going to hit compute here. So it'll give us toolpath, the pocket, and the finish. which I tried to use the 2-inch end mill. Let's grab the 3/8. There we go. Same thing for the outside. If I go in and select the actual boss extrude that was the entire shape, that's what it's going to pick for. Now, it didn't give me a depth because of the way that I made that extrude. I don't remember exactly which way I went, but it's defining it as a 0 depth. I would need to either click pick bottom and pick a bottom edge, or I could just type in the value. Now we'll actually add a chamfer. I'm not going to go too crazy with the profile rough and finish since we just talked about those, but we'll add a chamfer in. Make sure these are set to a realistic tool. Like I said, I'm not too worried about some of these values. Let's just get down to the chamfer mill. Now chamfering, something that I always like to bring up is that you don't need to go crazy defining your tools here. When you're setting up a chamfer mill, just define the diameter. We're going to do the rest of it for you a little bit later on. So even if your tool is a different diameter, different angle, different small diameter, don't worry about it. It's your sharp tool, flat tool, none of that really matters at this point. So let's just say it's a 1/4 inch diameter. Now the patterns are going to look just like profile. Left or right compensation. In this case, we want to do right. Then you have your tool position. So this is the cutter position. So if you're using an inserted cutter, you're going to have a 32nd or 15th thou radius on that insert. Sometimes it's as small as 8 thou, but generally it's about a 32nd. And usually that's what I use for my cutter position, just to get past that arc, just that radius. Otherwise, you're going to be left with a little scoop at the bottom of your chamfer. Same thing with sharp tools. A lot of times you don't have a real good cutting edge on the tip, and you want to offset that a little bit. So that's what this first value is for. And again, if you're ever not sure about something, try clicking in the box and it will show you what it's for. Small diameter only matters if you're running a flat tool. Now, if you're not sure what your small diameter is, usually what I do is I'll just take that tool and kind of spin it on a piece of tape or something just to kind of scratch it, just to see and measure what that diameter is, or something to mark a part to see what the diameter is, if you don't already know. Now, if you're using a sharp tool, you can omit that value. It doesn't matter. You cannot enter 0. It's just going to tell you to set it to sharp. But if I look back at the tool page, now it's defining that tool as a sharp tool. So it actually changed my tool information. So again, don't go too crazy defining your chamfer mills, because it could potentially change when you get here. Then you have your chamfer angle. So if I say 30, and I go back to the tool, now my tool is at 60-degree angle. It will change your tool based on the information you give it here. We have our depth. Let's just say we want to go 25 thou. Now you do have a depth, length, or width. So if you have an odd shape chamfer, maybe a 60 or 30 degree or something like that, and they give you a length or width, we'll do all the figure in to find out what that depth is. You also have single or multiple depth. So you can do this as a depth of cut and a step over, or you can just do it as a depth of cut. So if you just need multiple passes to get to your final depth, you can. We're just going to set it to single depth. Then we have our lead in and lead out. Let's just do a blend on there. I realize I deleted all that before we actually looked at the lead in, lead outs. So I apologize. We'll set this back up to do that. And I don't really need the rest of these pages, so we'll just hit next all the way through and hit compute. Now it's on the wrong side of the line again. I'm just going to go to reverse direction and then recompute. Now when you do reverse direction, it is just going to leave it at the same lead in position. So I want to go to modify. Let's go ahead and just move that up here and recompute again. All right. Let's go back to check this out real fast. Now we're going to open things up for Q&A here in a few minutes. So if any of you guys have any questions, feel free to start typing those in, and we'll be able to take a look at them here in a moment. Now, because of those internal corners and the tooling I used, it did not leave a good corner. So if I go back into my feature, the reason it did that is I did not look at my tool. So if I right-click the profile finish and hit edit, it's using a 1/2 inch. I want to use a 3/16. So that means my first profile on the inside is probably doing the same thing. Yep. Because I never actually saved that tool to my tool crib. It never saved it to it. So now when I run the simulation, it should look a little bit better. Now it actually looks right. Now a few things in here when you're running simulation. Let's go ahead and restart this. Let's say all I want to do is take a look at the chamfer. I want to see how that starts and how it enters, how it exits. I just want to look at the chamfer mill. It has not run anything at the moment. Let's make our stock show. If I click chamfer mill in the move list, it's going to load the simulation up to that point. So now I can scroll in and actually see what this tool is doing. And as if I start scrolling my mouse wheel through this little window, I'm going to see every one of those little data points for this toolpath. So how it's engaged, how far that cutter is in based on that chamfer cutting position, and how that chamfer is coming out. So you can kind of step-by-step move through these. You can also step forward. Just going to step through each one of those moves. Now you're probably noticing that my simulation's turning red, the tool's turning red, I got all these red X's. That's because I have Machine Simulation Pro, and when you do not set the work offset, it is inside of the table. Because G54 is the top, it's 0. When we define the machine, 0 is the tabletop. That's why we have all these offsets down at the bottom of your machine setup. That's what these are for. But you don't need to worry about it if you don't have Machine Simulation Pro. You're not going to run into this. All right. Now, last but not least, if I want to post my code, I right-click Milling Job and go to Post. You can do a post and save as. However, I just normally post and then save. Just what I'm used to. You can also go into the NC editor. So if you have to change anything, you just right-click in this window, go to NC Editor. It'll launch the editor where you can modify your G-code. If you have the upgraded editor, you can actually run the backplot on here. So if I go to Simulate, I can actually run let's turn a bunch of this stuff off here. I can actually have it run through the G-code and show me a simulation of that G-code. So if any of you guys have the upgraded editor and you're having trouble with that, let us know, because it does require a couple of things. There's this line at the top that gives us all the information for the job, the tooling, the stock, and all that. But also you have to have your template set up. So if your template's not set up for your G-code, you may run into a lot of errors. Like down here, you can get errors if it's set up for the wrong machine. So just be aware, if you're trying to use the NC editor, don't freak out if it's throwing up a bunch of errors. It might just be that you're using the wrong template. So we're going to open things up for Q&A for right now. This afternoon, we're going to take a look at more of the milling. We're going to take a look at drilling, kind of additional ways to select stuff and go about using the tool paths. So if any of you guys have any questions, by all means, let us know. I'm going to be right back, and then we'll field any of those questions you guys might have. All right, I am back. So if any of you guys have any questions, let me know. We're going to keep it open for a little while, and then if nobody asks anything shortly, we'll probably break for lunch a little bit early. But like I said, this afternoon we're going to take a look at the drilling, a little bit more of the different geometry selections and stuff like that. So if you have any questions, let me know. It doesn't look like we have any questions so far. Like I say, if anybody has any questions, let me know. If not, we'll probably close down the meeting in about another 10, 15 minutes or so and break for lunch. So yeah, if any of you guys have any questions, let me know. All right, so it doesn't look like we have any questions this half of the day, so we're going to go ahead and break for now. We're going to break for our lunch. We will be back at 1 Eastern, and we will continue then.